Hello and welcome to 8.2 Solving Systems of Equations Algebraically. We're going to learn two methods, first of all by substitution, and then we will do by elimination. You will be expected to know how to do both of these methods. You can, however, often choose whichever one you like better or whichever one you find quicker. So starting off with substitution, we have three steps. First, we want to solve one equation for either variable. Step 2, substitute that value into the other equation and solve for the other variable. And step 3, fill in the solved value into either equation to find the other variable. Okay, now this sounds confusing. When we see the step-by-step what we're doing, it actually isn't too bad. So let's start off with step 1. Solve one equation for either variable. We can see that that is already done for us by solve one equation for either variable. Basically, we want to get either y or x by itself. So let's go ahead and use this first one then. Let's say y equals 2x plus 1. Okay, so we have y by itself. Step 2 then is to plug in this 2x plus 1 for y into the other equation. Alright, so I'm going to write down our other equation, which is y equals negative 3x plus 6. And I'm going to sub 2x plus 1 in for y. Okay, at this point we've seen this before. We have one variable. We know how to solve for one variable. So let's go ahead and do that. I'm going to add 3x on both sides to get rid of our negative 3x. That gives us 5x plus 1 equals 6. I'm going to bring that 1 to the other side by subtracting 1. Gives me 5x equals 5, which leaves us with x equals 1 when we divide both sides by 5. Okay, so now I know what x is. We go on to step 3, which is fill in this solved value into either equation to find our other variable. So we can use again whichever equation. I'm going to use the first one. We have y equals 2x plus 1. I'm going to plug 1 in wherever I have an x. We can go ahead and solve that. So we get 2 plus 1, so y equals 3. So for this system of equations then, the solution, okay, or the intersection point is when x equals 1 and when y equals 3. All right, similarly to what we did graphically, we can go ahead and verify this by subbing these values into our equations. We're going to do that later on, so we won't worry about it right now. Let's go on to our next question then. This time we are asked to solve and then verify. So let's start off again. At step 1, we want to get either y or x by itself. Usually we want to do this the easiest way possible. So if we look at that first equation, it's going to be pretty easy to get y by itself. So let's go ahead and do that. So if we start with 5x minus y equals 10, if we add y to both sides, then we get 5x equals 10 plus y. And then let's go ahead and subtract that 10 from both sides. We get 5x minus 10 equals y. Okay, our next step then, we want to plug that y, which is 5x minus 10, into our other equation. Okay, the next step then is to go ahead and plug this into our other equation. So if I have x squared plus x minus 2y equals 0, wherever I see a y, I now put this 5x minus 10. So I get x squared plus x minus 2 times 5x minus 10, which equals y. Which equals 0. Then we can go ahead and simplify this, so I get x squared plus x minus, again we bring that 2 into both terms, so we get negative 10x and plus 20 equals 0. Simplify further, combining like terms, we get x squared minus 9x plus 20 equals 0. So where our factoring comes in, again, we want to see what multiplies to give me 20 and adds to give me negative 9. Well, that's going to be a negative 5 and a negative 4. So our roots then are at x equals 5 and x equals 4. So we see that we're going to have two solutions for this system of equations. We have those two roots. Okay, so let's go ahead and plug both those into either equation now for step 3 to solve for our y. So I'm going to choose that first equation. It's a little bit easier. 5x minus y equals 10. Again, plug in that 5 for my x. Multiplying that out, we get 25 equals 10 plus y. Bringing that 10 over, 15 equals y. Okay, then let's go ahead and plug in our 4 now. Again, remember we had both solutions, or we had both roots. So back to 5x minus y equals 10. If I plug in a 4 this time, I get 20 equals 10 plus y. Subtracting 10 from both sides, we get 10 equals y. So our solutions for this system of equation then are 5, 15, and 4, 10. All right, go ahead, pause the video and try to verify these solutions. This is what we had done yesterday with our graphically solving. Once you're ready, go ahead and hit play and see how you did. Okay, so hopefully when you verified this, you found that both equations did work for both solutions, as I found. You can see the work there for what you would need to do for full marks. Okay, let's move on then. Here we have 2x squared minus 7x plus 3, and y equals negative x squared plus 6x minus 7. So again, let's go ahead, pause the video, see if you can work through those steps for solving it, and then we'll go ahead and work through it together. Okay, so step 1, getting one of our variables by itself. We already have that. So step 2 then, let's plug that y into our other equation. Okay, so I'm going to choose our first equation, and I'm going to plug that into our other one. So what we would have is y equals negative x squared plus 6x minus 7. I'm going to plug our first y in there. So we'd get 2x squared minus 7x plus 3 equals negative x squared plus 6x minus 7. Let's go ahead and simplify this now. I'm going to bring that negative x squared to the other side by adding x squared. That gives us 3x squareds on the left side. Now I'm going to bring this 6x over to the left side as well by subtracting 6x. That gives us negative 13x. And then I'm also going to bring that 7 over because it's looking like we're going to want to factor this. So I'm going to add 7, which gives us plus 10 equal to 0. Let's go ahead and factor this by grouping. So we're going to want to split up that 13x in the middle into something we can work with. So let's take 3x squared minus 10x minus 3x plus 10. Now we see that we can take out an x from our first two terms to leave us with 3x minus 10, and we can take out 1 from our second set of terms to leave us with 3x minus 10. Again, taking that negative 1 out there. Okay, remember up here when we're splitting up to get these terms, we're looking for something that we're going to be able to get our common factor for this next step, which is when we can take out that common factor. So I can take out my x minus 1 and my 3x minus 10. Again, seeing that 3x minus 10 is a common factor of both terms in this equation. It's equal to 0. leaving us with x equals 1 and x equals 10 over 3. All right, step 3 then is to sub in these values into our equations to figure out what our y is equal to. So let's go ahead and do that. Again, choose whichever equation seems easier to use. Either one works at this point. I'm going to choose the first one, plug in my 1 for wherever we see an x. We end up with -2. Okay, so one solution at 1, -2. And then let's also plug in our 10 over 3. So we get 10 over 3 wherever we had an x. You can go ahead and solve that. Eventually we should get 17 over 9, leaving us with another solution at 10 over 3, 17 over 9. If you'd like, go ahead and verify this just to get some practice with that, but I think we will find that both solutions work for our system of equations.